Let's look at a quick review of solving systems of equations. Okay, so first we will look at substitution. So for example, let's look at this system. Negative x plus y equals negative 5, and 2x minus 5y equals 1. So first, we will solve one of the equations for one of the variables. It doesn't matter which equation for which variable, but often it's easier to solve one of the equations for one of the variables. So you would want to look for one of the equations where you have a variable that doesn't have a visible coefficient or a coefficient of 1. So for example, in this first equation, the y has a coefficient of 1, and the x has a coefficient of -1, so it also would not be that difficult to solve for. But I'm going to choose the first equation and solve for y. So I have negative x plus y equals negative 5. I will add x to both sides, and y equals negative 5 plus x. Step 2. Then we will substitute that result into the other equation, and it needs to be the other equation. So we have 2x minus 5, but instead of the y, we will substitute in negative 5 plus x. And we'll put that in parentheses, and then equals 1. And then we will solve this resulting equation for the remaining variable. In this case, that's x. So I have 2x. I'll distribute the negative 5. Negative 5 times negative 5 is positive 25. Negative 5 times x is negative 5x equals 1. I have 2x and negative 5x. That gives us negative 3x plus 25 equals 1. Subtract 25 from both sides. Negative 3x equals negative 24. Divide both sides by negative 3. X equals 8. Next, substitute the value we just found in number 3 into the equation that we found in step 1. You could also substitute it back into either original equation, but it's just easier to substitute it into the equation that we found in step 1. So I'll put 8 into y equals negative 5 plus x. I'll put the 8 in for x. So y equals negative 5 plus 8, or y equals 3. So that gives us our solution of x equals 8, y equals 3. Or as a coordinate, 8, 3. And technically we would check this by substituting x equals 8, y equals 3 into both equations individually and checking to see if both equations were true. I'm not going to actually do that step here, but that's how you would check. And you would have to do it for both equations. Okay, let's look at elimination. So for elimination, we'll use the system 2x plus 3y equals negative 16 and 5x minus 10y equals 30. So our first step here will be to choose a variable to eliminate. And we could choose x, we could choose y. Sometimes it's easier to choose one over the other. We might have a system where we have a variable where they have the same coefficient, but one is positive and one is negative already. And with the same actual values, just one's positive, one's negative. So if we were to add the equations together, that variable would already eliminate, and that would be the variable we would choose. Or we might have a system where we would just need to multiply one equation by a value. Here we don't have a simple one. I wanted to do a more complicated one. So we could choose x or y. I'm going to choose y. Then we'll find a common multiple of the coefficients of the variable that we chose to eliminate and find what number we need to multiply each equation by so that the variable that we're choosing to eliminate has the same coefficient, but one is positive, one is negative. So if I look at my y coefficients, I have a 3, I have a negative 10. A common multiple is 30. So that means I can multiply my first equation by 10 and my second equation by 3. My y in my second equation already has a negative, so I didn't need to worry about multiplying by a positive or a negative. I'm just going to multiply by positive 10 in the first equation and positive 3 in the second equation. So when I multiply the first equation by positive 10, I get 20x plus 30y equals negative 160. When I multiply the second equation by 3, I end up with 15x minus 30y equals 90. So step 3, we'll add the equations together and solve for the variable that is not eliminated. Because if we did our step 2 correctly, we should be eliminating a variable in this step. When we add these equations, 20x plus 15x gives us 35x. The 30y and the negative 30y cancel, so y is eliminated. And then negative 160 plus 90 is negative 70. So if we continue solving, I'll divide both sides by 35. X equals negative 2. Next, we will substitute the value we just found in either of the original equations, and then solve for the other variable. I'm going to choose the first equation, but again, it doesn't matter which one. So 2 times negative 2 plus 3y equals negative 16, or negative 4 plus 3y equals negative 16. I'll add 4 to both sides. 3y equals negative 12. I'll divide both sides by 3. Y equals negative 4. So our solution is x equals negative 2, y equals negative 4, or as a coordinate, we have negative 2 comma negative 4. And again, we could check by substituting our x value of negative 2 and our y value of negative 4 into both of the original equations to check to make sure that both equations are true when we do that substitution. Again, I'm not going to do that here, but that's what you would do. Okay, let's look at graphing quickly. So the system that we will solve by graphing, we'll use 2x plus y equals negative 8 and x minus y equals negative 1. To solve by graphing, well, there are a couple different ways. I'm going to use the way where we will put the equations in the form y equals mx plus b. So the first equation, 2x plus y equals negative 8. I will subtract 2x from both sides and I get y equals negative 2x minus 8. I'll call this equation 1. The second equation, x minus y equals negative 1. I'll subtract x from both sides. I have negative y equals negative x minus 1. I'll divide all my terms by negative 1. And I'll have y equals x plus 1. And I'll call this equation number 2. Then we will graph both equations on the same coordinate plane. We'll first plot the y-intercept. Then we'll use the slope to find or to plot a second point. So I'm going to do that on the next slide. So I'm going to start by just writing those equations again. Our first one was y equals negative 2x minus 8. Our second one was y equals x plus y. Here's a coordinate plane. So that first equation, my y-intercept is negative 8. I'll plot that point. My slope is negative 2 or negative 2 over 1. So I will go down 2 and write 1. I can reverse that and get another point, and another point, and a few more points to help me draw a straight line, and I can connect them. I only need 2 points to draw a straight line, but the more points I have, the easier it is to draw a line. Now for my second one, my y-intercept is 1, so I'll plot that point. I don't see a number in front of the x, but that means my coefficient is 1, my slope is 1, or 1 over 1, so I can rise 1 and go right 1, and I can plot another point, and another point, and another point, and then I can draw my line, and they intersect. My solution is the intersection point. And you can see the point where they intersect right here. It has coordinate -3, -2, or x equals -3, y equals -2. Again, we could check this by substituting those values into both of the original equations to check to make sure that both of those equations are true.